You know that iconic picture of Earth, the blue marble? Well, it turns out most of that blue is a total mystery to us. We're going to dive into what is truly the last frontier, right here on our own planet, the vast, unexplored ocean. Okay, let's just start with a number that is, well, it's kind of hard to wrap your head around. Over 80% of our ocean is still unmapped, unobserved, and completely unexplored. And I'm not kidding, we have more detailed, high-resolution maps of Mars and the Moon than we do of our own seafloor. Why? It's because the radio waves we use to map other planets just get swallowed up by water. To see the bottom, we have to use sound, and that means sending ships back and forth, which is just incredibly slow. And you've got to stop thinking of the deep ocean as just empty water. It's not. It's more like a collection of, well, alien planets, each one with its own unique, extreme rules for survival, all hidden right here under the waves. So, here's the game plan for our deep dive today. First, we'll look at why the ocean is still such a mystery. Then, we're going to journey into these worlds of absolutely crushing pressure and eternal darkness. And finally, we'll talk about the urgent race that's on to explore it all. All right, let's get into it. So first up, the big question, why? I mean, really, why is the largest, most critical habitat on Earth still such a black box to us? Well, the answer comes down to a few pretty extreme physical challenges. Think of these as the four horsemen of deep-sea exploration. You've got pressure so intense it can implode most submarines in an instant. The darkness is absolute, not a single photon of light. Temperatures can swing wildly from near freezing to literally hundreds of degrees Celsius. And on top of all that, these places are just so remote and so difficult to even get to. Okay, let's zoom in on that first obstacle, pressure. This isn't just some minor inconvenience. It is a fundamental, life-altering force that has sculpted some of the most bizarre and incredibly tough creatures you can imagine, all living in the planet's deepest canyons. To give you an idea of what we're dealing with, here, at sea level, we're all feeling about 1 atmosphere of pressure, or 1 ATM. Down at the bottom of the Mariana Trench, it's over 1,000 times that. That's like having the weight of 50 jumbo jets stacked right on top of you. It's just a completely different reality. These ultra-deep regions have a name, and it's pretty fitting. The Hadal zone. Yeah, named after Hades, the underworld. These are these geologically unique trenches that form where tectonic plates smash into each other. Each one is basically an isolated island of evolution, a little pocket world cut off from the rest of the ocean. So, you're probably asking, what on earth could possibly live there? Well, I want you to meet the amphipod. These little shrimp-like critters are the undisputed masters of the deep. They've evolved these incredible adaptations to just thrive in pressures that would turn a military-grade submarine into a pancake. It's just an amazing testament to how tenacious life can be. Now, let's move on to the next great mystery. At these depths, there's zero sunlight. It is perpetual, absolute darkness. So, without the sun driving photosynthesis, the foundation of basically all life on the surface, how can entire ecosystems even exist? And this is the crucial point. Life up here, it runs on solar power. But life in the deep, it runs on a totally different operating system. One that's powered by the raw energy of the planet itself. And what's so fascinating here is you see two completely different extreme solutions to the same problem. You've got these ridiculously hot hydrothermal vents fueled by chemicals like hydrogen sulfide, and then you have near-freezing oceans under the Antarctic ice, where life is fueled by minerals, both of them thriving in total darkness. These hydrothermal vents are just spectacular. I mean, picture these underwater geysers building these huge mineral spires, just blasting out water hot enough to melt lead. And right there, in that chaos, entire communities of creatures are thriving. They're powered by something called chemosynthesis. Basically, it's life that eats chemicals like hydrogen sulfide instead of sunlight. It's a world built entirely on chemistry. And then you have the complete opposite end of the spectrum. We're talking hundreds of meters under the Antarctic ice sheet in water that's actually below freezing, around -2 degrees Celsius. And life is down there, getting its energy by reacting with minerals. And this is why this is so important. It gives us a real-world model for how life might actually exist on icy moons in our own solar system, like Europa. Okay, so this brings us to our final and maybe most critical section, because this isn't just about scientific curiosity anymore. We are in a race against time. Our impact on the planet is reaching these unexplored places way faster than our understanding of them is.
Take the abyssal plains. You might picture the seafloor as all mountains and canyons, but actually, these vast, seemingly empty plains are the single largest habitat on our planet. They cover about half of the Earth's surface, and the microbes living in that mud play this huge but poorly understood role in regulating our global climate by storing away carbon. Or consider the Twilight Zone, that layer of ocean between about 200 and 1,000 meters down. Some scientists estimate it could hold up to 10 times more fish by weight than all of the world's commercial fisheries combined. It is an absolutely immense reservoir of life that we know so little about. So here's the bottom line, the so what of all this. These unseen parts of our world are not separate from us. They are the planet's engine room. They regulate our climate, they store massive amounts of carbon, they drive the nutrient cycles for the whole ocean, and they're a library of biodiversity we've barely even begun to read. And here is the problem, laid out visually. This low bar, that's our scientific understanding. This high bar, that's the rapidly growing list of threats. The gap between what we know and what we're about to lose is getting wider every single day. The main threats right now are commercial deep-sea mining and the relentless march of climate change. We are running the very real risk of destroying these fragile, ancient ecosystems and losing species that took millions of years to evolve before we even have a chance to know they exist. So, how do we win this race? The future really lies in technology. We're talking about developing swarms of autonomous robots that can map the seafloor around the clock, using high-resolution sonar to see what's really down there, and using new techniques like sampling environmental DNA from a cup of water to instantly reveal all the life hiding in it. The deep ocean holds wonders we can't even begin to imagine right now. New life forms, new geology, maybe even secrets to our own origins. The race is on to discover them. But the real question is, will we find them before they're lost forever? Honestly, the future of our planet might just depend on it.